order pairs to equations, or finding linear equations. We can find a linear equation, one, using the slope and the point, or also, option number two, through two given points. So let's visit first using the slope and the point. So in order to find a linear equation, by using the slope and the point, one, substitute the given value of the slope m into the equation y equals mx plus b. Two, substitute the coordinates of the given point into your equation from step 1 and solve for b. 3. Substitute the value of b from step 2 into the equation from step 1. And 4. Check the graph of your equation contains the given points. Okay, so let's start with this example. We have in this case, given that the slope m equals 2 and the point -2, -3. Find an equation. Do be aware, in this case, we do not have the y-intercept. So we gotta figure out the y-intercept. And luckily we're given the slope. So that means in our equation, y equals mx plus b, we know the slope is m, and the y-intercept of the value is the v value, agreed? Okay, for the y-intercept we give our full answer as a coordinate, 0, b, within that coordinate or set of parentheses. Okay, we can figure it out in two different methods. Do notice, I would definitely prefer that you figure it out through the left side, but it's entirely up to you. If you've used the right side format of the equation, notice we have a set of parentheses. On the left side, y minus y, and let's add 1, minus y1, equals m and times set of parentheses, x minus x of 1, meaning you're using the coordinate for that one. It often tends to give some or many students headaches, but it's sometimes used. So if you like using that, you're welcome to use it, okay? There's nothing wrong with it. It's just that I'm so used to using the one on the left side that it becomes easier in many cases. So I'll leave it for reference, but we'll come back to it in a minute. For now, let's notice that we were given that the slope m equals 2. And in our equation y equals mx plus b, that means we can substitute or replace the m value with a 2. There we go. So replacing the m with a 2, that's our first step. Substituting the given slope into your equation. Step number 2, we're given the coordinate. So substitute the x and y values of this coordinate into your equation, y equals 2x plus b. So there we go, y equals negative, or y is replaced by -3, x is replaced by -2, and let's remember that we were already given the slope, so we already replaced the slope. Once you substitute the slope value, it doesn't change. It remains there for the rest of the equation. Okay. So 2 times -2 gives us -4, so we have -3 equals -4 plus b. And finally, we want to solve for b. So we want to get rid of the 4 from the right side. So add 4 to both sides to get rid of it. -3 plus 4 gives us 1. On the right side, -4 plus 4 cancels out or gives us 0. In other words, all we have left is the b value on the right side. So b equals 1. This tells us that our y-intercept is 0, 1. We know the y-intercept value now. Okay, that means we can plug it into our equation. We previously figured the slope, right? So this is the third step. Y equals 2x plus b. So our v value, once again, is 1, so we can replace the v value with a 1 now. So now our final equation, y equals 2x plus 1. And there it is. Last step, step number 4, is to check. We will graph that in a minute. Let's first take a look at the other form of the equation. And let's notice we can actually use it, and it'll give us the exact same answer. But for some reason, in many cases, it becomes a little more complex depending on what you're used to using. So, going back to the top, on the right side, we have the slope, m equals 2. So in the equation above, all we're doing is substituting the slope, m value, with the 2. There's our m value substituted. And now we're going to use the coordinate, -2, -3. Just as before, but in this case, in our other formula. It looks a little more complex, so do be aware of it, but it's not necessarily. Okay, replacing the y1 and x1 in this equation, we have negative 3's and negative 2 in their places. And now we simplify this. Notice on the left side, we don't really need the parentheses. So it becomes y plus 3. On the right side, we do need the parentheses, but first we simplify the sign. Negative times a negative on the 2 gives us a positive 2. So it's x plus 2 in the parentheses. And now we distribute the 2. So 2 times x is 2x, 2 times 2 gives us 4. So that gives the expression or equation y plus x equals 2x plus 4. And now we want to solve for y or leave y all by itself, meaning get rid of the 3. So subtracting 3 for both sides, there we go. Plus 3 minus 3 cancels out or gives us 0, leaving us the y by itself. So that will become y equals. And now on the right side, we have 2x, and then 4 minus 3 will give us positive 1, which gives us the same equation as what we got on our other form of the equation. So 2 different forms of the equation. Once again, that will give you the exact same answer. But for some reason, the second format tends to give some students a hard time. So be aware, try using the left side. So if you see the right side equation and haven't used it before, I recommend just stick with the one on the left side. If you've seen the one on the right and have no issues with it, go ahead and use it. It's still doable, okay? So be aware, it gives you the same answer. But it takes a little bit more effort in some cases. So now let's try graphing it. Let's graph the y-intercept. But first let's label the x and y axis. And now for the y-intercept. So there is our y-intercept at 0, 1. And our slope tells us slope is 2. So it's 2 over 1 technically. You can always put over 1. So we're going to go up 2 and over 1. So up 1, 2, and then over 1. There's our next dot. So in reality, all we need is 2 dots. I recommend 3 or more dots just to make it a little bit more clear that it's definitely a linear format. But for this case, I'm just going to use 2 and make a line through that. The last thing we want to do is step number 4 was to check. Check that the values given are part of our answer. So we check our slope by graphing it. Agreed? And now negative 2, negative 3, we want to check and make sure it's on the line. So let's graph negative 2, negative 3, and let's see if it's on the line. So there it is. Negative 2 in the x, negative 3 in the y, and it lands on our line. So definitely we just check that it works. This is the line that we wanted to calculate.